Hey everyone, welcome back to Tech Junior Tutorials. My name's Lee Warwick Jr. and we're talking about admin of code. Today is Christmas, so Merry Christmas or Happy Holidays or whatever you celebrate. But today or in this video, we're going to talk about day 21 of admin of code. So let's check out that puzzle. Here's the admin of code website. Clicking on day 21, this is the Springdroid adventure. So this is another ink code problem. Check out days like every other day. I think this started on day 2 or 3, and then has progressed to a finished ink code computer in day 9, I want to say. And so we've just been using it since then. So the ink code problems have typically been, they started out really hard, and then they sort of become have become fun problems and kind of like a break between really difficult puzzles. So the puzzle before this one in the previous video was a maze where you're like looping through this recursive maze, which sounds ridiculous. Today we're actually running ink code. We're going to run a script that is going to solve for a robot. And so the puzzle for today, what it says is you're flying to or from Pluto in the direction of Santa, and you get into some kind of asteroid belt or something that hits your ship and causes hull damage. And so you need to get a droid and program it so that it can jump the holes in your ship and survey the damage, basically. So this is the actual, this is crazy, like this is the actual output of encode for today. So the puzzle input is, where are we at? Is just a big encode computer input. So this is a program for the encode computer that we wrote, big array of numbers. And what it's going to output, which is like crazy, is ASCII values one at a time. And so basically if you concatenate all those, turn them into letters, and then print it, it will print messages, whatever. So in this case, it's literally going to print this. So that was great. The code for this is super short. So if you look at my code, this is my encode stuff. So I just like collapse that. So the top 134 lines are all encode stuff. My code for the solution is, I don't know, like 50 lines, including like a lot of extra fun stuff. So what I've done is I've got some stuff to run encode, and they say for the puzzle itself, you are going to be writing Springdroid commands. So you're going to be giving it these values. It's a little bit tricky to parse this because to us, we want to read it, in letters, but encode is going to take that in ASCII values one at a time. So it is going to need like the value N and the value 0, or I'm sorry, O, and then T. It's going to need a space, A, space, J, and then a new line character. All the way down until the end, where it's going to need a walk, which is going to tell it like, hey, we're done, go ahead and run the code, and then another new line. So to parse that, you've got to take each line, break it into characters, reverse that array, at least for me, reverse that array, and then concatenate it all together, and then basically whenever encode asks for it, I just pop off of that giant array of commands. So it receives the input values like one at a time until it receives WALK and ASCII with a new line at the end, and it stops asking. And then it just runs the code, crunches whatever numbers it's going to crunch. So to do that in Python, I've got two different ways that I do it. So the first way I did it was I made it so that I could input manual commands. So what that looks like is basically I type the commands one at a time, and then as I type them, I save that to the string. I strip space in case I fat finger something. Go ahead and uppercase all of it because it is expecting uppercase letters. And then I append that to my input list as another list. So I make a 2D list. And the reason I do that is so that I can reverse that, so I can get where my last command is going to be walk, so I need in the other direction. So I need like walk to be last. And then I'm going to, for each command, take each line and bust that into a bunch, like convert it to ASCII values. So this is what this list comprehension does. It takes each character in the command array. So I've already busted it out into a list. Sorry, I meant not array, a list in Python. So I take the word that's been split into a list, make a new list that's the same values but in ASCII. Then I reverse that because I want, remember the last letter that I would type would be like J, but I want to get N first to feed to encode because I'm going to be popping off the end of the array. You could probably do like slices or something, but I just figured it was easier to run pop. So I do that, and then I have an actual array of encode commands, which is going to be all the ASCII values, so a flattened list of ASCII values. And so that is going to be just a bunch of like list concatenations. So I concatenate all that together. It gives me one giant list of numbers. So if we go ahead and run this, I'm going to run it in manual mode. Can't type on camera. This is going to ask me for a command. I will say not a J, so that we'll get to this in a second, but that says if you don't have a tile in front of you, if you have a hole in front of you, go ahead and jump. So I'll do that. I'll do walk. And then that is going to actually print all this stuff from encode. So I had to code this, and we'll talk about that. But here's the actual ASCII values. So this is NOT, 32 is space, 65 is A, 32 space, J, and the new line is 10. And then this is WALK 10. I left that in there for debugging purposes, just to make sure that I was actually inputting all these, like doing all this fancy array stuff correctly. And then for my output function, all that is going to do is basically, I've got a function. So the way I wrote encode, I'm a JavaScript person normally. JavaScript's very like functional leaning. So I'm used to writing everything as a function. So wrote encode as a function, its helper function is a function, and then the Springdroid function has two functions, and then those, the scope of those, so one is going to reach outside of itself and into the upper scope and use this encode input list to pop off values. So every time encode calls inputter, it gets the top value off of that array, and then outputter, every time it calls that, it's going to pass in some ASCII number, and then it is going to concatenate that to another upper scoped variable up here and just add that value. And so basically I smash all those together and then print them whenever the program is done. And this ternary statement here in the instructions, it says whenever it successfully runs, it will spit out a value that's like way outside of the ASCII range. So I cannot remember, I still haven't looked it up since the last video, what the actual amount of ASCII values is in total. I think it's like 200 something, but it seems like they always spit out a number in the tens of thousands or millions or something like that. So I just say basically if they give me a number that's huge, turn it into a string, add that to output string. Otherwise, it's an ASCII value, change it into a letter, and then concatenate that. So that's why I get this pretty output in my terminal. I tried to animate this and make it like display the robot jumping into the hole, and I could not get it to work. I tried and tried and tried. I probably should have spent more time working on the Spring script instead of that, but that's where we're at. So I made it so that I could manually input commands if I wanted to, but that is kind of tough. So the other thing that I did was I added some code that will read from a file. So I make a second text file, and I call this script.springcode, or maybe I should have flipped it and called it springcode.script, whatever. But I basically made my own parser for lines of code. I went ahead and, since I'm doing Python, I kept the same convention of using a hashtag as a comment. So all these lines are commented, and in the code, I basically parse this file, split it into lines, and then for each line, I say, hey, if the line is empty or if it starts with a hashtag, ignore it. Otherwise, go ahead and do the same thing as these commands up here, essentially, and make everything into a list, strip space and uppercase everything, and add a new line character. And then I go ahead and take that, reverse it, and do the same stuff as before. So we can see, so I'll go ahead and comment these out. And uncomment this. So I need a comment on the first one. So if we run this now, there it goes and gives you all the input instructions. So let's get rid of that. What this does now is it just prints everything, reads these values, turns them into this giant output or ASCII list of numbers, and then it takes these off the end one at a time and feeds it to encode. And then that is a correct encode program, and so it spits out the answer. But let's talk about what it took to actually understand and get this code to work, because it was not easy. If we look at the instructions, so they say you're going to be writing in Springdroid, which is like some made-up language. And what it is, it's a language that only has two variables. There's like t, which is your throwaway variable, and then j, which is what it looks at the end. And if j is true, the robot will jump. So for every space that it walks on, down here, every space that it walks on, it is going to look possible 4 values ahead of it. And it's going to say, like, you have to write some kind of logic limited to 20 lines that looks at these spaces, decides, like, hey, is there a hole there, or a hole there, or a hole there, or a hole there, and whether or not you should jump or not. So what they say is, like, they give you a example. They say, like, not D, jump. So the commands that you have, basically what this does is it says, hey, anytime I see a hole, jump into it. So it's a useless program, but this is position A. If you're standing on this spot, so like that's not counted because you're standing on it. A, B, C, D, that's as far as you can look. They say if D is a hole, so when you get here, like, oh, that's a hole. They don't tell you, but the robot jumps 4 places. So 1, 2, 3, 4. It'll always jump to position D. So if it says, like, not D, not being the opposite. So if D is there, it's true. So not D. So if D is false and you not it, it becomes true. And then that saves it to J. And so J becomes true and it says jump. So that jumps right into the hole, which we can see if we do, let's do this here. So there it does the same thing, jumps right into the hole. So the other operators that you get are and, or, and of course not, we just talked about. So this is like, when I read this yesterday, it just blew my mind. I didn't want to think about it. I did not want to write this Spring script code or whatever. I'm already learning Python for this. I didn't really care to learn this throwaway language for this one puzzle. So that was kind of annoying, but I feel like I learned a lesson along the way. So in any case, so for each one of these things, it's kind of like, the problem is, how do you write a program when you only have these 3 comparison operators? You don't have logical branches, so you can't do if or else or anything like that. You've only got these 3, and at the end, it looks at the one variable that you get, J. And if J is true, it jumps. And in these comparisons, it says if both values are true, it's going to rewrite whatever's in y. So that could be t or j. So this just like is super hard to think in, especially because you're talking about inverse logic. So the only direct writing operation that you have is not. So not only looks at the first value and then will like definitely write something to y. So like if x is false, so if in this case like we're looking at not a, if a is not there, j will be false. Or I'm sorry, if a is not there, j will be true. Otherwise, it will just stay false. So if there's no a, j always becomes true, no matter what the value of j is. The other two look at y. So when you say and tj, both of these values have to be true for j to become true. So that like we're so used to as programmers looking at three values, like, okay, if t and j are true, then like some third value will be rewritten as true or do something else. We're working with the same values. So that is like a huge paradigm shift when you're thinking. And it's very, very confusing to think about. So when I wrote this the first time, I got lucky and basically fiddled with it for 10 minutes until I basically stumbled upon a solution. So I'm not really 100% on what this does. I know that it works. It pops out this number, which is the solution for part 1. Reading Reddit, there's like a bunch of different solutions out there. Many possible inputs that can solve this for you. But what I understand this one does is it looks at C and it says if there's no C, D becomes true. And the space D is there. So like here, if that's position C, if that position is empty and D isn't, so if D is solid ground, because you always land on D, that says if there's a hole at C and D is there, jump. And then that is stored in variable T. So not C becomes T and D, so it says like T should be true if there's a hole. And then if there's also not a hole at D, then T becomes true. And then this last or penultimate line says if there's not a solid ground point on the next tile, jump. So then it says at the very end, or T or J. So if there's a hole at A or at C, jump. Or if there's a hole at A or at C and ground at D, jump. And all that is in 4 lines. So that's really hard to think about, but it works. So great. Did not help me for part 2 because part 2 is a lot more difficult. So for part 2, which is, it's always scary whenever you get part 2 and it's like really short. They say like, okay, instead of using walk, use run. And that is going to give you 5 more spaces that you can look ahead. So now you can look 9 tiles in front of you instead of just 4. So that increases the possibility for disaster. So basically what had happened when I did this was I would do a lot of trial and error and be like, okay, clearly I got to this point and I looked at A and I looked at B and I saw that C was empty and D was solid. And so I jumped and then I got to point here, which is like I should jump again. I'm not looking at place A, right? So that was helpful, but whenever we do run, so I don't even look at position B, but when we do run, now you can see we end up with this problem where now we are jumping too early and then we put ourselves in a spot where we can't jump to solid ground again. So now you jump again, but you land in a hole. So you have like a double jump scenario, right? So what happened is I jumped too soon. So I looked at, right here, I looked at position C and said, oh, there's a hole, D is there, let's jump. But I didn't realize that E was a hole and H was also a hole. So basically, I fiddled with this a whole lot. I think I had to like, I don't know, I've got my notes here that I've like scribbled down over and over on how to solve this. I don't know what I ended up doing, like and H I ended up thinking. Yeah. So I was like, okay, well, position H is where I fell in the hole. So here I tried it again, and I hit the same problem where now instead of jumping there, I waited a space and jumped and then fell in a hole. So the logic that I landed on after like scrolling through Reddit and getting really frustrated with this, trying to like brute force it, was that just scrolling through people talking about it. They were talking about positions E and H, which I kind of already saw doing this. And I saw a lot of different solutions on there, a lot of different programs that would solve it. And I didn't understand any of them. So I barely understood what this was doing. I dang sure didn't understand what they were doing because they were like solving all kinds of problems and like writing to all these, like concatenating T and J together to make one big logical operator for J. And I just wasn't prepared last night mentally to do that. And so I tried to just stumble upon a solution, which just didn't happen. So, what I ended up doing was rewriting this. So I found a second solution that solves a couple of edge cases in the first one. So like namely B. This, which I spent a lot of time on pen and paper, I've actually got a lot of explanation for it here. So what this basically says in total, this program, so this is part one, like that I actually thought about. It says if A is a hole, or B is a hole, or C is a hole, and D is ground, jump. So I can prove that it works. Run this. You can see we get the answer. But why does it work? So what I saw a lot of people doing was kind of writing this and then translating it to Spring code. So that's what I ended up using my pad of paper for and doing all of that. I don't know if you can see my scribble. I've got a lot of these notes here. So I basically translated that into these comments in my Spring script. And so first I look at A and say like, okay, if there's no A, save that to J. If there's no B, save that to T. Then I say, if there's one or the other, like compare the two. And if either one is true, save that to J. So that creates, like right off the bat, this like combination of the two conditions. Then I don't care about C at this point. So I overwrite C and say like, okay, or I'm sorry, T. Say if there's no spot at C, put that in T. And then here, where I do this or T or J again, that is like concatenating the logic or combining the logic that I've stored into J with what I now have in T. So that becomes this. Like if there's no C or there's no B or there's no A, store it to J. And then when I say and D, J, that means both of these have to be true. So I have to have D as ground plus one of these to be true for it to jump. And that's kind of how I ended up learning to crack this. So obviously that's not enough to solve it, but what I eventually looked at and saw with E and H was, this is the solution for part 2. In the end, I needed this, which is, I won't show you my notepad again, but this is what I scribbled on my notepad, right there. So I needed the same thing as part 1, but I needed to expand it and say like, okay, E has to be solid if I'm going to jump. So definitely want to jump if there's A, B, or C, because that's as far ahead as I can, like that's as far as I can jump over basically. But I need to look ahead and see like if I need to double jump. And so I also will only jump if there is a spot in E or a spot in H, which is what these edge cases here are showing. So like that move, I shouldn't have jumped here. I should have waited, or actually, I shouldn't have waited there. I should have jumped earlier, because here, got B or A, B, C, and D, but E is empty, so that should have told me to jump. F, G, H. So H is there, and I have a hole in C, and there's solid ground in D, but E is empty, but H is there, so that tells me I should jump. However, I don't. I wait, and then I'm in a spot where I've got A is empty, D is empty, so I end up jumping anyway, but I land in the hole, so there was like, basically once you get there, there's nowhere to win, or no way to win, because you're going to jump directly into a hole or fall into one. So that was the logic I landed on. How I actually got there, though, was the hard part. Well, I'll take that back. The hard part was like forcing myself to sit down and think about this, because I did not want to. I wanted to move on to the other puzzles because I thought they were more exciting or more fun. So I was trying to rush myself and get through this really fast. Looking at the scatter plot for this, like day 21, I think we're talking about. Yeah, day 21 is not as exciting as the other ones. People kind of buzz through it. I'm really anxious to get to this puzzle right here because it looks pretty difficult. Looking ahead at like days 24 and 25, they also look pretty fun. So they might be hopefully not too difficult, but pretty interesting to work on. This like assembly basically program that we were doing did not like interest me at all, and so I wanted to just rush through it and get it done. And that was my failing on this one. So that was the lesson that I had to learn. But in any case, so how I got there was I started with my rewritten part 1 solution, and then I took that and I saved it in T. So T became this original solution from what I had in J. Then I went ahead and flipped T to be true, whatever it was. And then I looked at E, and I said, if I'm basically, T is like you're jumping. So if I'm have a spot in E and I'm jumping, save that in T, or I have H, save that in T, that eventually, so like remember J is this. So I created T being true if E or H is true, and then I did another and at the end. So J was this originally, and then this is now T, and so that is how I concatenated it together. And so it takes a second to crunch this giant number, but that is the final answer for this one. Basically, like if you got a number, you knew that you had solved it, because otherwise, like your ink code computers, you probably already knew that was broken. But so just seeing this number pop out, I was like ecstatic that I finally solved this one, because it was so dang tough. What changes we have here? Yeah, we don't need to worry about that. So that's what I've got for day 21. Most of the difficulty was not actually in the programming part. It was basically a logic puzzle. So learning how to write Spring and getting into people have described it as like what assembly would look like. If that's true, I'd never want to work in assembly because this was not fun in my opinion. The puzzle itself is fun. Getting it to work is fun. It's really cool that I've been able to code this so that I basically have like a parser for a language, right? That's pretty cool. But actually writing the language itself, miserable. Having to think in these kind of terms. I'm sure watching this video, you're watching this and going, what the heck is Lee talking about? Because I don't understand any of this. Believe me, I felt the same way looking at people's solutions on Reddit. Trying to look at hints, like I would see their programs. And at first I just skimmed by them. I was like, oh, I don't want to look at the answer. And then I actually stopped and read them and I was like, it doesn't even matter if I read them because I don't understand what they do. So I can't even spoil the solution without literally copying it and pasting it in and seeing if it works. So I did that just to verify that like ink code wasn't broken or something and other people's solutions worked. There's multiple solutions for part 2 as well. I was just happy to get one of them. But yeah, this was a very difficult one in my opinion. Really hard to think about. Really hard to reason in this very limited amount of like variables and stuff. So very difficult. The next puzzle that we're going to be doing is a shuffling deck of cards thing. It looks pretty straightforward for part 1. Part 2 is actually one of the more difficult looking puzzles so far. It's like the highest time to solve part 2 on the graph so far. So if you look at this, it is this one. So it's narrowly beating out day 18 part 2, which was also a pretty dang tough puzzle. So somebody mentioned modular math. I don't know what that is. I am hoping that I can solve it, but I don't know. I'm going to get to work on it now. Part 1 looks really straightforward, so it seems to be the case here. We'll see how part 2 goes. All right, that's all I got for this one. Like, subscribe, follow, all that good stuff. Hit me up on Twitter at Lee Warwick Jr. or hit us up at Tech Junior Podcast for the podcast. I will see you on day 22, hopefully when I solve it.